The Portable Operating System Interface is a family of standards specified by the IEEE Computer Society for maintaining compatibility between operating systems. POSIX defines the application programming interface, along with command line shells and utility interfaces, for software compatibility with variants of Unix and other operating systems. Name. Originally, the name POSIX referred to IEEE STD 1003.1-1988, released in 1988. The family of POSIX standards is formally designated as IEEE 1003 and the international standard name is ISO IEC 9945. The standards emerged from a project that began circa 1985. Richard Stallman suggested the name POSIX to the IEEE instead of former IEEE-IX. The committee found it more easily pronounceable and memorable, and thus adopted it. Overview. Unix was selected as the basis for a standard system interface partly because it was manufacturer-neutral. However, several major versions of Unix existed, so there was a need to develop a common denominator system. The POSIX specifications for Unix-like operating systems originally consisted of a single document for the core programming interface, but eventually grew to 19 separate documents. The standardized user command line and scripting interface were based on the Unix system V shell. Many user-level programs, services, and utilities were also standardized, along with required program-level services. POSIX also defines a standard threading library API which is supported by most modern operating systems. Nowadays, most parts of POSIX are combined into a single standard. As of 2014, POSIX documentation is divided in two parts: POSIX 1 2013 edition, POSIX base definitions, system interfaces and commands and utilities. POSIX conformance testing. A test suite for POSIX accompanies the standard VSX-PCTS of the VSX POSIX conformance test suite. The development of the POSIX standard takes place in the Austin Group. Versions. Before 1997, POSIX comprised several standards. POSIX 1 Core Services, Process Creation and Control, Signals, Floating Point Exceptions, Segmentation, Memory Violations, Illegal Instructions, Bus Errors, Timers, File and Directory Operations, Pipes, Library I/O Port Interface and Control Process Triggers. POSIX 1B Real-Time Extensions, Priority Scheduling, Real-Time Signal Clocks and Timers, Semaphores, Message Passing, Shared Memory, Asynchronous and Synchronous I/O Memory Locking Interface. POSIX 1C Threads, Extensions, Thread Creation, Control and Cleanup, Thread Scheduling, Thread Synchronization, Signal Handling. POSIX 2 Shell and Utilities, Command Interpreter Utility Programs. After 1997, the Austin Group developed the POSIX revisions. The specifications are known under the name Single Unix Specification, before they become a POSIX standard when formally approved by the ISO. POSIX 1-2001 equates to the Single Unix Specification version 3. This standard consisted of the base definitions Issue 6, the system interfaces and headers Issue 6, the commands and utilities Issue 6. POSIX 1-2004 IEEE STD 1003.1-2004 involved a minor update of POSIX 1-2001. It incorporated two minor updates, or errata referred to as technical corrigenda. Its contents are available on the web. POSIX 1-2008 as of 2016. Base Specifications Issue 7 represents the current version. A free online copy is available. This standard consists of the base definitions Issue 7, the system interfaces and headers Issue 7, the commands and utilities Issue 7, the rationale volume. Controversies 512 versus 1024-byte blocks. POSIX mandates 512-byte block sizes for the def and do utilities, reflecting the default size of blocks on disks. When Richard Stallman and the new team were implementing POSIX for the new operating system, they objected to this on the grounds that most people think in terms of 1024-byte blocks. The environment variable POSIX_ly_correct was introduced to allow the user to force the standards compliant behavior. The variable name POSIX_me_harder was also discussed. The variable POSIX_ly_correct is now also used for a number of other behavior quirks, where POSIX and common sense disagree. POSIX-oriented operating systems, depending upon the degree of compliance with the standards, one can classify operating systems as fully or partly POSIX compatible. Certified products can be found at the IEEE's website. POSIX certified. Some versions of the following operating systems have been certified to conform to one or more of the various POSIX standards. This means that they pass the automated conformance tests. X, HPUX, IRIX, OSX, Solaris, TRU64, Unixware, QNX Neutrino, INSPORK-AUX, Integrity. Mostly POSIX compliant. The following, while not officially certified as POSIX compatible, comply in large part: Android, BIOS, Contiki, Darwin, FreeBSD, Alumos, Linux, Minix, MPEX, and ETBSD. Nucleus RTOS, NUTTX, OpenBSD, OpenSolaris, PyKios RTOS for embedded systems with optional PSE51 and PSE52 partitions. See partition. RTEMS POSIX API support designed to IEEE STD 1003.13-2003 PSE52, Sanos, Skyus, Syllable, VSDA, VxWorks, Xenix. POSIX for Windows. Cygwin provides a largely POSIX-compliant development and runtime environment for Microsoft Windows. MingW, a fork of Cygwin, provides a less POSIX-compliant development environment and supports compatible C-programmed applications via MSVCRT. Microsoft's old Visual C runtime library. Microsoft POSIX subsystem, an optional Windows subsystem included in Windows NT-based operating systems up to Windows 2000. POSIX-1 as it stood in 1990 revision, without threads as sockets. Interisks, originally opened by Software Systems, Inc., is an upgrade and replacement for Microsoft POSIX subsystem that was purchased by Microsoft in 1999. It was initially marketed as a standalone, add-on product and then later included it as a component in Windows services for Unix and finally incorporated it as a component in Windows Server 2003 R2 and later Windows OS releases under the name Subsystem for Unix-based applications, later made deprecated in 2012 and dropped in 2013. It enables full POSIX compliance for certain Microsoft Windows products. UWIN from it and AMPT Research implements a POSIX layer on top of the Win32 APIS. Mks Toolkit, originally created for MS-DOS, is a software package produced and maintained by Mks Inc. that provides a Unix-like environment for scripting, connectivity and porting Unix and Linux software to both 32 and 64-bit Microsoft Windows systems. A subset of it was included in the first release of Windows Services for Unix in 1998. Windows C Runtime Library and Windows Sockets API implement commonly used POSIX API functions for file, time, environment, and socket access, although the support remains largely incomplete and not fully interoperable with POSIX-compliant implementations. Mostly POSIX-compliant environments for OS/2, Mks plus GCC, largely POSIX-compliant. POSIX for DOS. Partially POSIX-compliant environments for DOS include Mks plus GCC, largely POSIX-compliant. DJGPP, partially POSIX-compliant. Dr. DOS Multitasking Core via EMM386 Multi, a POSIX Threads front-end API extension is available. Compliant via compatibility feature. The following are not officially certified as POSIX compatible, but they conform in large part to the standards by implementing POSIX support via some sort of compatibility feature. Without these features, they are usually non-compliant. ECOS POSIX is part of standard distribution and used by many applications. External links section below has more information. Morphos, OpenEVMs, Plan 9 from Bell Labs Ape, ANSI, POSIX environment, Riot, Symbian OS with pips. Windows NT kernel when using Microsoft SFU 3.5 or SUA. Windows 2000 Server a professional with Service Pack 3 or later. To be POSIX compliant, one must activate optional features of Windows NT and Windows 2000 Server. Windows XP Professional with Service Pack 1 or later. Windows Server 2008 and Ultimate and Enterprise versions of Windows Vista, albeit deprecated, still available for Windows Server 2012 and Enterprise version of Windows 8. Unix system services that runs on Z OS.